Hello. Welcome to Action Squared channel. Do you know what the subfactorial of a number n is? The subfactorial of n, denoted by an exclamation mark followed by n, is used to calculate the number of derangements of n elements. To better understand what this means, let's start with a quick review on factorial. The factorial of a non-negative integer n, or n factorial, is denoted by n followed by the exclamation mark, and is equal to the product of all the integers from n down to 1. Accordingly, the factorial of n is equal to the product of n and the factorial of its predecessor. Also, by definition, the factorial of 0 is 1. Due to being somewhat counterintuitive, this statement deserves a separate video. For our purposes, just assume it is true. One of the main applications of factorial is in computing the number of permutation of elements. Assume n elements a1, a2, a3, up to an, which need to be organized in an arbitrary order. Then, there are n options to choose for the first element. There are n-1 options for the second element. And this process continues until there is just one option for the last element. The product of the options, which goes from n to 1, or n factorial, gives the total number of possible permutations. For example, if there are two elements a and b, the permutations are ab and ba. And the number of permutations is equal to 2 factorial, or 2. If there are three elements a, b and c, the permutations are abc, acb, bac, bca, cab, and cba. And the number of permutations is equal to 3 factorial, or 6. If, instead of counting all the possible permutations, the goal is finding just the number of derangements, or the permutations where no element is kept in the same position of a predefined first orderly arrangement, then this is given by the subfactorial of number of elements n. The subfactorial of n is equal to n factorial times, sum from k equals 0 to n, of -1 to the power of k, over k factorial. For two elements, if the first arrangement is ab, the only other possible derangement is ba, subfactorial of 2 is 1. For three elements, if the first arrangement is abc, the only other possible derangements are bca and cab, subfactorial of 3 is 2. Now let's find the difference between subfactorial of n plus 1 and subfactorial of n. Applying the formula of the subfactorial of n to both terms leads to n plus 1 factorial times sum from k equals 0 to n plus 1 of -1 to the power of k over k factorial minus n factorial times sum from k equals 0 to n of -1 to the power of k over k factorial. Next, let's extract the last term from the first sum. So, the brackets receive -1 to the power of n plus 1 over n plus 1 factorial, plus the sum from k equals 0 just up to n, of -1 to the power of k over k factorial. Expand the expression. Replace n plus 1 factorial of the second term for its equivalent expression n plus 1 times n factorial. Make the appropriate simplifications. The difference between n plus 1 subfactorial and n subfactorial is equal to -1 to the power of n plus 1, plus n times, n factorial times, the sum from k equals 0 to n, of -1 to the power of k, over k factorial. Note that the sum in the last term is exactly the subfactorial of n. Hence, the difference between n plus 1 subfactorial and n subfactorial is equal to -1 to the power of n plus 1, plus n times n subfactorial. From this expression, it is possible to get the value of n plus 1 subfactorial in terms of n subfactorial. N plus 1 subfactorial is equal to -1 to the power of n plus 1, plus n plus 1 times n subfactorial. Examples, for subfactorial is equal to 9. 5 subfactorial is equal to 44. 6 subfactorial is equal to 265. Back to a set of 4 elements, there are 4 factorial or 24 possible permutations. If the orderly arrangement is ABCD, therefore subfactorial or 9 related derangements are the cells highlighted in blue in the table. If the orderly arrangement changes to CBAD, the 9 derangements change accordingly to the new highlighted cells. I would invite you to do the same for a set of 5 elements. But, nah. You got the idea. If you like this content, please support us by liking this video, subscribing to our channel, and turning the notifications bell on. Hope to see you in the next video. Thank you.